Hello, so I'm just creating this video tutorial to show you how to plot orbitals in 3D. So let me share my screen, okay, so I can actually show you this. And so right now, let me show you this PowerPoint. So remember the wave function psi, we put it as a product of two different wave function, R, which is the radial distribution function, and psi of y of theta and phi. These uh, y of theta and phi are what we call the spherical harmonics. Okay, now we need to plot this in spherical coordinates. So we know that the x is sine of theta cosine of phi, y sine of theta sine of phi, and z is cosine of theta, and then they're multiplied by r using the square. So what we're going to put here, this is this part, your radial distribution function, a square, okay? And basically we're just going to put this in a program called GeoGebra, and we're going to be able to plot these surfaces. So if you remember, the 1s orbital is basically your radial distribution function, okay, times a constant. This is your spherical harmonic, that constant. So the s orbital is just a number, okay, a constant. So in that y squared that we saw earlier for x, y, and z, here, that's what we're just going to put a constant, that number. The p orbital, again, is a radial distribution function. So you have that constant number, and then you have sine of theta, cosine of phi. That will be the important part that we're going to put it here, okay, square. And that's how we just do this plot, okay? So what we need to do now, you just need to go online, and you're going to call a program called GeoGebra, okay? Type geogebra.org, and it will show up. You can either just use it online, where it is, or you can just sign up for an account, okay? So the first thing you will see it is, say here, graphing. You need to change these to 3D calculator, okay? 3D calculator, you're going to see different panels here for the 3D calculator. And here is what we're going to type. So we first going to plot the s orbital, and the s orbital is just a constant, so I'm just going to leave it as a 1, number 1. So we're going to type surface, okay, parentheses, and then we need to put the values of x, y, and z, and then we're going to give the quantities for theta and phi. Theta goes from 0 to pi, and phi goes from 0 to 2 pi. So since I'm going to use for y a constant, you're going to use 1, so I'm not going to type 1. You can type 1 or 2 or 3, whatever value you want to use. So first thing, the x is sine of theta, sine of theta. We can go here, AB, and then just theta, okay, cosine phi, phi here, and then comma. Then let's go to the y, which is sine of theta, comma, sine of theta, sorry, sine of phi. So we'll pick phi here. Then you see it's getting a little cramped. What I do is I just squeeze this all the way to the side until I finish typing, so I can see everything. Just bring this back, type here A, B, and then use the Greek letters. And then let's go to the Z, and Z is just cosine of theta here. And then let's go to the values. So theta here goes from 0 to comma 2 pi. So I'm going to put 2 and then going to type pi. Okay. And then phi here goes from 0 to 2 pi. Actually, this is going 0 to pi, not to 2 pi theta. So put it here. Actually, I already plot the sphere here. I'm just going to bring this back, and we're going to see it here. Make it bigger if you want. The sphere. There's a lot of stuff here you can do. We can actually show the grids, you know, if you want. That's not necessary. You can even show a plane. Just the plane here. You don't have to do that. I don't like to do that actually. Just like to take this off. So that's your s orbital. You see how easy? Now let's plot the p orbital. So the p orbital is just very similar. You're going to have x, y, z. It's just in front of it, instead of a 1, you're going to put your wave function for the p orbital for the spherical harmonic, which is sine of theta, cosine of phi, as we saw before. So what I'm going to do, I'm just going to duplicate the input. So, and then I'm just going to modify this one. So that surface, the x, I'm going to multiply by sine of theta squared cosine of phi squared. Okay, so sine of theta, put here theta. I'm just gonna close it here, and then the little hat just to do square, and then use the arrows to go down again. Cosine of phi. Just gonna take phi here, and then that will be also square. Put here square. Okay, and then multiply by my x. Then I'm gonna do the same thing with the y. So in the y, I'm gonna put again sine of theta, and then I'm gonna square that, square. Use the arrows to go down, cosine phi, and then that will be square. Okay, that's gonna be multiplied by my y, and then the z value, cosine of theta, which is a z axis, right, will be sine of theta here times cosine phi here, phi. Okay, and I forgot to square these, so that's sine of theta. It's gonna be square. Okay, use the arrows to go down. And sine of theta will be also square. Okay, so hopefully that will show now my p orbital, which is inside of the s orbital. So let me unclick the s orbital so you can just see the p orbital. So that's a p orbital. Okay, you see here, that's my p orbital. Just using values x, y, and z. Okay, this is it for the tutorial. Hopefully you like it, and that will be all. Stop this. Go back here. Stop. Okay.